Hallo und guten Tag. Hello and welcome. Today I'll talk about accessible data visualization, which is important because many forms of data visualizations today are not inclusive and accessible. And I will mainly focus on color shapes and providing additional formats. To my person, I'm Nieuwenhuis. I also work at QZ as the speaker before. And I am studying media informatics. I'm about to graduate. Media informatics roughly translates to media informatics. At least that's the official translation. Not a really good one, but that's not the point. First of all, I'll be speaking about why we're doing this. There are certain laws and regulations for web accessibility. Then I will explain what is accessibility. Then I'll present our accessible color palette, the types of constraints we had, the palette itself, and also the ordering of the colors for color vision deficiencies. Then I'll go on to talk about additional visual clues. We developed certain markers and patterns, and these are made available via an SVG generator. And then more formats, additional formats, non-visual ones, example, providing alternative data formats like tables, and a short section on area labels in different visualization libraries. And I will also take a short part showing you how to implement these different patterns in Bouquet and Vega-Altair. As I mentioned, data visualizations and generally many forms of web content often exclude users with visual impairments. And of course, we want to include them, but we don't only want to, we also have to. As an example, we in Europe now in the EU have the European Accessibility Act, which roughly mandates accessibility in digital spaces. And it's already in effect, effective since June 2025. But don't freak out, there are certain transition periods, but like starting from 2030, basically all web content has to be accessible. The specifications for like what you have to implement are in the EU norm 301549, and they roughly mirror the WCAG, the Web Consortium Accessibility Guidelines 2.1 level AA. If you never heard of WCAG, this is the accessibility guidelines published by the W3C, and W3 is the consortium basically publishing all web standards. And this EU regulation has already been ratified in Germany in the Barrierefreiheitsstärkungsgesetz, beautiful word. And the EAA mandates that basically all consumer-facing content has to be accessible. So from websites, but also like there are certain regulations on hardware. For example, if you're programming a ticket sales machine, that also has to become accessible. Most people, companies, website representatives have to comply. The only real exemption are micro-enterprises, meaning enterprises with fewer than 10 employees and an annual turnover of under 2 million. And if it like implementing the accessibility would like fundamentally change your product or would just be too expensive, there are also certain exemptions for that, but you also have to provide like proof that it's too complicated, too expensive, and whatever. And another big regulation are the American laws, namely the American Disability Act and the Rehabilitation Act. the American Disability Act was already effective in 1990, and it doesn't speak about web content specifically. It just mentions that places of public accommodation have to be accessible. But nowadays, many law courts have decided that, like websites, web forums, everything is also a place of public accommodation. And the Rehabilitation Act has mainly two sections for talking about the accessibility. Section 508 requires all federal agencies and all organizations that receive federal funds to have accessible web presentations, and the Section 504 extends that a bit. Now that I scared and bored you enough, I'll talk about what I'll be presenting. We as a company, we publish the QZ design system. That's an open design system, open source, everybody can contribute. On the website you'll find like links to how to make the fork, how to contribute your own content. We do instructions for everything web content, not only about accessibility but also about inclusive writing, and we present different solutions, software solutions, web components that are like modular and flexible. And we have a big section on database that we are currently expanding. And yeah, that was the main part I was working on, was making the database more accessible. But first of all, what's meant by accessibility? Like the traditional sense is often that it's about people with like permanent disabilities or impairments, but the more like current definition also includes temporary impairments, like you have some ear infection and you want to have like audio transcription for web contents, or just like situational impairments when you're, for example, outside in the sun and you can't read your screen, or it's really loud and somebody sends you a voice message and you would also like to have a voice transcription. I've spoken about the WCAG a bit. These are the main principles presented in there. So content should be perceivable, meaning that you should have text alternatives, captions for videos and images, and your layout should be adaptable to different layouts, to different screen sizes and formats. They should be operable by all kinds of users with every kind of disability or impairment. For example, having a clear keyboard navigation with a clear structure that you can follow along whilst tabbing. Sufficient time limits for stuff that appears and disappears automatically. And no content should be like flickering, for example, to not give seizures to people with epilepsy. Of course, it should be understandable, like text should be readable, not only in Word, but also in text size. The navigation I already sort of talked about. And for inputs, there should be like alternative inputs or outputs also. If you think about like captchas that are sometimes really hard to read, and they also provide like an audio form of that. And these presences should also be robust, meaning they should be compatible with all kinds of assistive technologies, for example, screen readers. More on that a bit later. And yeah, now I come to the many constraints that we had whilst developing an accessible color palette for the web. We, of course, didn't only want an accessible color palette, but we also wanted it to work for the modern web with compatibility to light mode, to dark mode. And we as many of the laws required. We wanted to comply with WCAG accessibility level AA, and that requires smaller text to have a contrast of at least 4.5 to 1, and visual elements and their colors to have a contrast of at least 3 to 1. This is the formula for calculating the contrast. It's not that important. It's basically dividing the relative luminance of the lighter color by the relative luminance of the darker color, and then applying this transformation here. Just to be said, the part with the X is the part you have to apply for RGB the same, so I didn't want to make it 3 times. And when you apply this formula, you can calculate that the maximum contrast can be 21 to 1 for like a white color on a black background or other way around, which would make you think, that's fine. But actually, the formula is not linear. So if we have like a middle gray, like a luminance level in between white and black, we only have a contrast of 4.5 to 1. So we don't have like as much wiggle room to implement our colors. Next, we of course also want the colors to be not only differentiable in luminance, but also in the color itself. For that, we use the CIE delta E calculations. You might have heard that from like calibrating monitors and calculating color differences in that. This is the formula for that is in CIE lab color space, which is a much larger color space than the web color space sRGB. But still, we aim to like comply with the transformation from LIB to sRGB. We wanted to have a delta E of at least 20. And to visualize that a bit, the big part here is the LIB color space. Quite a lot smaller part there is RGB. And the smallest area here is CMYK, so like for print and such. And that leads us to our next constraint. We didn't only want to provide colors for the web, but also maybe someone would like to print their data viz. So we try to find some colors that also fit into the CMYK color space. For that, we decided to go with the most common color space used in the EU, which is the CMYK ISO-coated V2. And because that was kind of hard to hit in some places, I'll show you next, we decided to also accept the Pantone C palette, which is also suitable for printing. These graphics show, like, on the one side, the full color circle, and on the other side, what's available from the color circle when you want to have full saturation in the CMYK format. This can, of course, be improved if you make it brighter, you have more hues, but then, of course, it's less saturated, less colorful. If you make it darker, you'll also have, again, more hues, but it's, again, less colorful. And then, of course, you can also reduce the saturation, but that, of course, less saturation, less colorful. And now I've talked about colorful. By that, I mean vividness. Vividness is a, like, so to speak, measurement, calculation, stemming from the HSV color space. HSV meaning hue, like the color tone, saturation meaning like the strength of the color, and the value is sort of like the brightness, inverse brightness. And to make colors fit together, it's nice to have a similar vividness level. So like the product of saturation and value. These nice constraints leads us to the next point. We want to order our colors so they have like maximum differentiability for color vision deficiencies. So here you see our palette. It's already ordered to make it less confusing in the end. And when you have the turinopia, which is a red-green color blindness, where the green color cones in your eyes are not working or missing, it will look about like that, of course simulated. For the other type of red-green color blindness, where you have red missing, it will look like that. For blue missing, like that. And if you don't have any color vision at all, you will have, it will look about like this. To visualize these palettes, I use the, I think it's called Stark Accessibility Checker. It's a browser extension where you can go on any website and open it, and you have different kinds of checks you can do about the typography. They also have automated auditing, but that costs, of course. It's not for free. But I mainly use the vision simulator, where you can just simulate like general vision deficiencies like blurry vision or cataracts, but they also have the main 4 types of color vision. Here again showing the no color vision. And that, of course, these are not that differentiable. So we decided we also want to have not only the colors, but also some shapes. So we developed, implemented one shape fitting to the color. And these can be used like as data markers in plots. But they can also be tiled in patterns, so you can fill area plots. And they can also be reduced in the density if you want to show a certain percentage. This is all implemented in SVG patterns. If you don't know, SVG stands for Scalable Vector Graphics. This is like a data exchange, mostly a graphics exchange in document format that has this like XML-like syntax. And going into it, the dev section is a definition section. Stuff you put in there won't directly show in the graphic. And in that I defined, so confusing, a pattern with an ID. The pattern has a width and a height, and the width and the height will be like one tile. And in that pattern, we define our base path. It can be any kind, like a rectangle, a circle. In this case, just a path. Also with an ID, the path itself and the color. And with a use tag, you can just reuse any kind of SVG element by referencing the ID, so you don't have to define it. And then you can put the translate transformation to move it around. And if you only have the dev section, nothing will be shown. You have to put like a shape to actually fill, in this case a rectangle. And here we reference the ID of the pattern itself as a fill, and this will fill it. If we now extend the view box and the width of the height of the rectangle, we got a nice tiling pattern. And if you don't have rectangular patterns, there are some helpful methods. You can rotate and skew the pattern before applying it, but please do your own reading on that. Now that we have these nice shapes and tiling patterns, we can also generate palettes, like sequential palettes in case of the purple here, and diverging palettes, example for hot to cold relations with red to cyan. And to make that available, I developed an SVG pattern generator. Here you can choose any one of our 8 or 9 patterns, and you can choose a percentage that scales the base if you want to show different percentages. And via these 2 buttons, you can download the tile you see there, or just a 1x1 tile if you only need that for, example, for a marker. Until now, this has mainly been about visual stuff, but we also want to make it accessible to users with who are blind, for example. So to display our color palette and the relations differences to each other, I programmed this sort of chord diagram which shows the relative differences between these via a tooltip. It also changes the color of the chords themselves. But this is, of course, looks fancy, but it's not really accessible. So we also include the table with all the color values and their delta E values to make it more accessible to screen readers. And next is implementation. It's a Jupyter notebook. I couldn't really fit it. It's a long web page. So we'll switch to the browser. So for implementation, we used the 2 libraries, Bouquet or Bouquet.js and Vega-Altair. They are both widely used and really nice for making interactive data visualizations for the web, where you can click around, zoom, filter data, and everything like that. For Bouquet, we can directly use the patterns in their files. We can, when you want to use it locally, convert it to base64 image, but we don't need to do that for web. And then we create a dictionary, building the data. We collect every one of the SVG files as an image texture. And then we give some example data and labels for the different colors. And then we generate the figure here as a vertical bar diagram. And to be able to use our SVG patterns, we have to use the output backend SVG, otherwise nothing will show up. The implementation in Vega-Altair is a bit different. We can't directly use the files. We have to somehow include the patterns in our web page or Jupyter notebook. So we read the file, and the trick is to give the whole image a viewbox of 0, so it won't show up visually, but it's there in the DOM available. Then we can use that. We have again some example data. And here the big part is we can reference the different patterns via DOM ID reference. And here again we have to use the SVG backend or renderer for displaying the SVG patterns. So I'm a bit short on time, but I'm also about on my last slide. Yeah, big point. You're creating these nice graphs and you include them in your website. But when you include them just as an image and they have certain area labels included in their SVG structure, screen readers won't be able to find them. When you want to make that available, you have to spread the SVG in your DOM, like in your browser. So not include it as an image, but put the whole SVG as code in the HTML. And that makes it available for screen readers. I've seen many websites where they have the example, look at this nice accessible SVG, but it wasn't accessible. And maybe if somebody developed a screen reader, they could implement the feature where it automatically fetches the SVG and puts it in place of the image. But that's, I'm not too big into that. And for Vega, there are different settings. You can set what will be shown in the SVG via ARIA labels and whatnot, and this will show up. Thanks a lot. Do you have any questions?
Thank you. Thank you, Maris. So we have one question online. I'm going to start off with that. But actually, it's more of a comment. Regarding accessibility, the documentation of the QC design system is only in German.
Yeah, that's true.
So maybe, will you work on that, or do you have plans for
I have to ask my boss. We'll work on that.
He's nodding at least. Yeah. So.
Yes,
okay.
We'll work on that. Yeah. It's quite a big project, so it will take some time, but we'll work on that step by step. Yeah.
Right, second one, that's probably also short. Data storytelling tells us to keep distraction at a minimum. Would you still recommend patterns on a graph or like a chart? So there seems to be some kind of conflict here, what this question points to.
Yeah, like sort of depends. If you more like want to tell the story and then maybe not have it accessible to everyone, I think when your story is like impactful enough, like a small pattern on the side isn't too distracting.
Or maybe data storytelling, sometimes you use only a few colors, right, to highlight specific, so you don't have to color everything. So
yes.
Yeah. Okay. So we had at least one question here in the room, right? Yeah.
Well, thank you for your presentation. The simple question, I think a lot of the tools that I've seen for accessibility testing are manual. Have you found any useful automated tools that could be, for example, used in like a test suite for verifying accessibility to some extent?
There are some automated ones. The most you find on the web are, you have to pay for them, for the audits. And I also read a section on the European Accessibility Act that not everything can be automated about that. And so, yeah, it's like partial process. Maybe you can implement some parts yourself via like UI testing with like Playwright or something like this. But I haven't found any like free open source tool for accessibility audits.
Thank you so much. And a small follow-up. You are very expert on this. Perhaps you could tell us a bit more about that requirement of like having a person test certain things, because that's quite fascinating. Do they need to be of that particular like disability, or can you simulate it? What are the options?
There's nothing like specifically written on who has to test what. There was just basically a comment that most automated tools will not be enough. And also there are different accessibility tools you can add as a plugin or like extension for your website. For example, WordPress overlay. These often also don't really comply because they make the website navigation itself more complicated. And what was the question again?
Thank you so much.
Okay, so last question, because I don't want to give you all an advantage for a disadvantage for the lunch out there.
It's more of an open question. Since accessibility is becoming mandatory in a couple of years, and if I export a PNG graphic, it's by definition not accessible for some people if they can't interpret the SVG, for instance. And does that mean that we should seriously think about phasing out Matplotlib, which is getting very old anyway?
Yeah, I think Matplotlib really isn't made for the web and for accessibility. I think it's more for like quick prototyping, and yeah, better use the library that's more compatible for that. And yeah, for like raster images, pixel formats like PNG, at least provide like an alt description and a caption. It's not in the regulation that you're not allowed to use raster images, but SVG has really nice features, and it's really great format. So I embrace the use of that.
All right, thank you everybody for being here. Thanks, Maris, for giving this wonderful talk. Enjoy your lunch, everybody.